Good morning, students, and welcome back. Let's continue working on this sleeve bearing. Of course, as I closed out the last chapter, I'm sure everyone was jumping up and down screaming, save the file, save the file, save the file. So I'll do that now. Here's the part number, the file name. I'll click save. I won't lose anything now when Solidworks crashes. Okay, so again, we have to put in these small 4mm diameter holes. These holes are at a weird angle of 30 degrees, and we're going to find out that there's a pretty straightforward way to accomplish that. To start with, I'm going to put holes in that are perpendicular and kind of take us through some interesting features inside of Solidworks to make them slanted at 30 degrees. So to start with, we are going to sketch on the top plane, and we're going to sketch a hole in this top plane 30 millimeters back from the front edge, and then we'll extrude cut that, and then we'll array it, and we'll see these 4 holes that are perpendicular to the axis of the sleeve bearing. Let's get to it. I click on top plane. I use the sketch command. I am going to click on this cut extrude 1, click on sketch 2, and tell Solidworks to show it, meaning I'm going to click on this eye. And now I'm going to use this tool called Convert Entities, and I'm going to click on that. I'll zoom in a little bit, and I'm going to click on my original center line and click on this one perpendicular line and click the green check mark. I now have copies of what I converted in my new sketch. They're solid lines. I want them to be construction lines, so I will select one. I'll press and hold Control, select the second one, and tell Solidworks to make both of them for construction. Notice up here under Selected Entities, I can see that I have line 3 and line 4, and those are the light blue lines. I'm going to click the green check, and those lines are now center lines in my sketch. I can immediately use the offset command. I'll type in 30 millimeters, click this right hand line, and tell Solidworks by clicking up here inside the part that I want it to go to the right. I'll click that line and make it a construction line. I'm ready to create a circle centered right about that point, so I'll use the circle command. I will highlight that snap point, bring my circle out, click a radius. Without moving my cursor now, I'm going to type the radius of that circle, which is 4.1 divided by 2. And click the green check mark. That's the only feature that I need to sketch to extrude, cut these holes. I will exit my sketch, use extrude cut, again choose through all both, and you can see that Solidworks is going to cut all the way through the top wall and all the way through the bottom wall. I'll click the green check mark to accept that. There's the top, there's the bottom. I'm going to circular pattern this feature as well so that I have 4 holes. I'm going to click my direction. Notice 6 is still what's stuck in here. Solidworks will always default back to the last prior selection in a feature. So I'm going to change my 6. I click in, I backspace, type 4, press enter, and I have a preview that tells me it's going to give me 4 holes around a circle. I'll click OK. And if I line this up, you can see I am cutting straight through the part. If you look carefully at the PDF that is posted online, you can see that we do not want them coming straight out. So let's fix that. This project browser, it shows me as a user what every object is that I've created, and it also shows me the order that I've created them in. This bottom bar, if I hover over it just right, shows me a wrist with the bar pinched between a thumb and a finger, and I can drag that bar back. And when I do this, those 4 holes are going to disappear. So this bar is like a time bar. I have dragged the state of my 3D model back in time before I created that cut extrude 2, which is actually what we want to do right now because we need to modify that cut extrude 2. So let's do that. I'm going to click on my front plane and I'm going to create some more geometry. I'm going to create a quote guide path that I want to use to guide the extrude cut of my 4 holes. So on front plane, I click sketch. I'm going to use convert entities again, so I'm going to click this convert entities command and choose that center line again. I'll click OK. I'm now going to draw another center line, and I did that by clicking the alternate arrow by line. Click on center line, zoom in a little bit, click my origin, come straight up, making sure that I see the yellow vertical preview, click it into place. I don't care what the length is in this particular case, but I want this line to be tipped to the right by 30 degrees. So with my line selected, I can choose the alternate arrow by move and tell Solidworks that I want to rotate it. And when I do this, we'll take you through the math and we're going to find out that Solidworks ignores me. So the first thing I need to choose is center of rotation. I want to rotate it about the origin, and I want to rotate it clockwise 30 degrees. The Solidworks coordinate system assumes that the x direction is 0 and counterclockwise is positive. So I want to move to the right or clockwise, so I want to enter negative 30 degrees. I should click the green check mark and it should rotate, but it's not going to. Well, that's really surprising. Well, we'll cover that in a different video. So I've got my 30 degrees. I'm pretty happy. I'm going to click the green check. I'm going to hit escape a couple times to get out of that command. I'm going to exit my sketch and notice that I have a sketch 4 sitting here in my project browser. So I'm going to roll my time bar forward and look at this extrude cut, and I can change that extrude cut by clicking on this first icon called Edit Feature. I go right back into the same command properties that I used to create this feature. And in this particular case, I'm going to change my through all both to through all. And I'm going to uncheck direction 2. And notice now I only get a whole cut preview on the bottom. That's fine. There's this blue box right here that doesn't really have a name by it, but instead of it cutting perpendicular to the sketch plane, I can cut in a different direction. I want to cut along the direction of this line. And so watch what happens when I click on this line. I get this angle. Well, and it's actually kind of backwards of what I'm looking for, but I can adjust that by telling Solidworks with this reverse direction icon that I want to reverse the direction of my cut. And it goes up and out the top. I'm going to accept this command. And notice now what's interesting is I still have all 4 holes. So my pattern was saying that I wanted 4 of these objects around 360 degrees. And when I cut through both the top and the bottom, I was actually cutting multiple times. Now if I have 1 hole and I pattern it around 360 degrees, I get 1 cut, 2 cuts, 3 cuts, 4 cuts. So sometimes Solidworks lets us cheat. So I click outside this part, and we have now sketched, created features, we've repeated that process, and we have a completed part. So we've gone through these patterns to copy those holes. As a last step, let's assign the material. That's going to happen over here in the project browser. So I'm going to click on material, right click, and say I want to edit the material. I get a big dialog box, and Solidworks has quite a few stock materials. There's an entire steel category, iron category, aluminum, copper, titanium, zinc, many metals, and some other kind of fabric materials. Then there are rubbers and woods, and where's plastic? It's in here too. Maybe it's other non-metals. But we're going to want a copper alloy. And I'm going to scroll down pretty close to the bottom and choose a tin bearing bronze. Right? We're modeling a sleeve bearing, and we're going to want to use a tin alloy. So I'm going to click apply, and notice that when I do the color changes, which is cool, but what's much more cool is that the material properties that are correct inside a bronze bearing are assigned to this part. There are mass densities, tensile strengths, and heat thermal conductivity properties. All of those can be used later in an engineering analysis to either do stress analysis, a center of gravity analysis, or some kind of heat conduction problem. Solidworks has all of those features inside. So for now, I'm going to click close, and our part looks like a really cool bronze part. And that's going to close the modeling portion of this assignment. And when we come back in the next chapter, we're going to start creating a 2D drawing for this part. Hope you enjoyed this video, and look forward to seeing you in the next chapter.